Hello and welcome back to another video. In this problem, we're asked to see whether inverse tangent is equal to inverse sine over inverse cosine. Now, the way that we're going to prove that this is false is with a counterexample. So we're going to take the value of x is equal to 1 and calculate it for these individual functions and compare. So tangent inverse of 1 equals, to figure this out, we can take a 45, 45, 90 triangle. The side lengths are 1, 1 to root 2 proportionally. And so we can see that the tangent of 45 degrees, which is pi over 4 radians, is equal to the opposite over the adjacent, 1 over 1, which is 1. Therefore, if tangent of pi over 4 is 1, tangent inverse of 1 is pi over 4. For sine inverse and cosine inverse, I think it's just going to be easiest to do this by looking at the graphs of these functions. So if we are looking at these functions, and I will draw them over the intervals in which we take their inverses, because obviously it's very restricted. So for sine, we go from negative pi over 2 to pi over 2. For cosine, we go from 0 to pi. If we went any further, then it would no longer be a one-to-one function and we can't take its inverse. So you're restricted to these values and say, okay, for what value of sine is, for what value of x is sine equal to 1? We can see right here that this occurs at, this is the sine function, occurs at pi over 2. What value does it happen for cosine? At x equals 0. So therefore, if we want to see that tangent inverse of 1 is equal to sine inverse of 1 over cosine inverse of 1, we plug in our values and get pi over 4 is equal to pi over 2 divided by 0. Of course, you can't divide by 0, so this is undefined. Therefore, these are not equal. And the statement we can then definitively say is false.